Okay, so we're going to look at how we can use a Cayley table even if you're not given the binary operation. Okay, so we've got a Cayley table here. The elements are going to be A, B, C, and D. You can see them written above the top and on the left. Okay, but we're not told what the binary operation is. And yet we can still find the identity and the inverses as well as some other things. So if we start with the identity E, okay, if we look, it's written as A, B, C, D here. So is there a row which is also written in that order? Well, it would be this row here. Okay, and that appears to be in the row for B. So I suspect the identity is going to be B. Now we can check columns as well. So we can see how this column is written as A, B, C, D. Is there a column written in the same way? Yes, it's this one. Okay, and that is the B column. Okay, so the identity would be B. Now for the inverses, if I write out A inverse, B inverse, C inverse, and D inverse. Now the identity is always self-inverse, so the inverse of B would just be B. Now if we do the inverse of A, say if I go to the row A and try and find where identity B is, it's right at the end in the column for D, so I can write D in here. And if D is the inverse of A, then A should be the inverse of D. I mean, you can check that using the table if you want. And finally, the inverse of C, if we look in the row for C, the identity B appears here, okay, and that is in the column for C, so that is a self-inverse element. Now, some other things we can do is we can actually do the combining under the binary operation using the Cayley table. So if we're asked to find A combined with B, I don't need to do any calculations. A is my left element, okay, here. B is my right element here. So therefore the output would be A. Okay, just like that. Now next on we got C combined with A combined with D. So work from the left. So C combined with A, so C, A would give me D. Okay, so this here is D. So we get D combined with D. So my next step is to go D and D, which gives me C. So that will be my final output. Now for our next one, we have D to the power of 3. Now that doesn't mean necessarily D multiplied by D multiplied by D. It's about combining under the binary operation. Now the binary operation might be multiplication, but we don't know. So I could write it like this, given that asterisk is being used as the binary operation here. So if we do D combined with D, we know that's going to be C. Okay, so then we're left with C combined with D. So C is our left element, D is our right, okay, and we end up with A as final output. Okay, final one here then. So we got AC squared, so we could write that as A combined with C combined with C. Okay, if we start by doing A combined with C, we have A combined with C, which gives me D. And then we still need to combine that with C to get our final answer. So D is our left element, our right is C, and that gives me A as my final answer.